Welcome back, friends. In the last session we started with the introduction to the data structures and the first data structure, that is one-dimensional array. In this video I am going to talk about the multi-dimensional array, that is two-dimensional arrays. Two-dimensional arrays is mainly useful to store different type of matrices, and let's learn how the elements of matrices are stored and retrieved later. So let's get started. So what is a two-dimensional array? It is nothing but the collection of similar data items but distributed over the rows and columns. As we know, in the matrix we have the number of rows and number of columns as well. And mainly it is used to store the different type of matrices. One of the example of the matrix I can give is to store the credits of 6 subjects of 4 students. So let's say I have the 4 students, student number 0, 1, 2, 3, which represents the row in the matrix, and the column number indicates the different subject. For example, subject 0, subject 1, so on. So student number 0 has achieved the credit of 5.6 in the subject 0, 7.6 in the subject 1, and so on. Let's see how I can store this multi-dimensional array in the C++. So to store the two-dimensional array, I can define the two-dimensional array directly by giving the number of rows and the number of columns. So the first bracket here indicates 4, which represents the number of rows, and the second bracket indicates that the number of columns. And the data type of each element of the two-dimensional array is going to be float. So it's up to you which data type you want to provide while declaration of this two-dimensional array. So here assume that I want to store the credits of 4 students and for the 6 subjects representing the different columns. So total number of elements that will be declared is 6 into 4, that is 24. Out of this 4th row, the first row, we call it as a 0th row, can be accessed with the help of credits 0 and 0. So the first bracket indicates the row number and the second bracket indicates the column number. So if I want to access all the elements of row 0, I can do that by providing the first bracket as 0 and the second bracket as the column number, starting with 0, 1, 2, etc. Similarly, I can access the first row with the help of this credits 1, 0 and the second row by providing the 2 in the first bracket. And that's how you can access all the elements by simply giving the index of row and index of the column. Now here is a piece of code to print the entire 2D array. I have written this outer for loop which loops from 0 to 3, and I have the inner for loop. J starts from 0 to 5. I will indicate my row number and J will indicate my column number. So initially I start with i's value as 0 and I print as student number 0. And for student 0, I am going to loop through all the subjects, that is all the columns here, and print the subject number and the credit obtained by the student. And here is the credit I and J, both are the variables in the first bracket as well as in the second bracket. And after the first loop, after the inner for loop, I have written the printf statement /n that will print my next row in the next line on the console. So that's how you can access all the elements, or you can, I can say, you can print all the elements of 2D array row by row and in the row column by column. Let's look at how the memory allocation happens for this two-dimensional array. Now from the programmer's point of view, this is the 2D data. Means we have the rows and columns. But when it comes to the memory, memory is always one-dimensional in nature. For example, there is a first location with the address 0, 1, 2, 3 and so on. So to store these 15 elements, we need to see how the memory allocation will happen for these 15 elements in the one-dimensional memory. So here is my two-dimensional array, total 15 elements, and here is the memory. Now consider I have just shown the memory horizontally here. So to store these 15 elements, what I am going to do, I am going to take one-dimensional array. Why I require one-dimensional array? Because memory is all one-dimensional. I cannot directly store these two-dimensional data structures in memory. To store it indirectly, I need to take 1D array and somehow I need to store these 15 elements in the one-dimensional array. Then I will load this one-dimensional array in the memory. And that's how the multi-dimensional arrays are stored in memory. No matter it is two-dimensional array or three-dimensional array or n-dimensional array, we have to first store the multi-dimensional arrays in 1D array and then 1D array will be stored in the memory. Now there are two ways of storing these 15 elements in the one-dimensional array. The first method is called as row major order, or I say I am going to store all these elements row by row in the one-dimensional array. So first of all, what will be the size of one-dimensional array? Those many elements I have in the 2D array. So here I have 3 into 5, that is total 15 elements. And to store these 15 elements, I need to declare an 1D array of size 15. But the question is, what will be the arrangement of these elements in this 1D array? So one of the method is called as row by row or row major order. Similarly, I have another method that is called as column major order. I am going to store the elements column by column. So first I will store the first column, then second column and so on. Let's look at the first method, that is row major order. So let me again take the same example. I have 3 rows and 5 columns here, and here is my 1D array. So by row major order, first row is going to be stored at the beginning of 1D array, means 5.6 element will be the first element of 1D array. 7.6, it is a row by row. So in the first row, from the index point of view, it is the 0th row. So from the 0th row, first element, second, third, fourth and fifth will be stored at the beginning of array. Now after these 5 elements, means after this first row I am going to store the next row. Remember, the row will be stored as it is in the 1D array. We are not randomly storing the elements from the row randomly in the memory, that is in the 1D array. I am going to sequentially store this all values, that is 8.2, 6.4, 8.1 and so on in the 1D array. And finally, the third row I am going to store at the last. So that's how I arrange all these elements row by row in the one-dimensional array. But remember, from the programmer's point of view, credits is the two-dimensional array. Means if he is going to access any element of this credits array, then he is going to provide the row number and the column number. And somehow that row number and column number has to be converted into the location in this 1D array. So with respect to I and j, that is row number and column number, let me show here value of I 0, 1, 2 and value of j varies from 0 to 4. So with respect to I and j, let me mark here all the positions of these elements in the one-dimensional array. So with respect to I and j, 0, 0th element is the first element of array, 0, 1 is the second element and so on. So this is the row 0 and these are the j value indicates the column number. So when the user says that I value is 0 and j value is 4, I need to locate this element in the 1D array. Similarly, here is the second row. From the index point of view, it is the first row that starts. So for I value 1 and j value 0 to 4 one more time. And similarly, the third row, I value is 2 and j value varies from 0 to 4. So let me say that total number of rows are capital M and here 3 and the number of columns represented by capital M, in this example 5. Now let's assume that this 1D array is loaded in memory starting with the address location 36. Assuming that one float element takes 4 bytes, the second element in the array will start from 40 because 36, 37, 38 and 39, 4 memory locations will be used by the first element. So the next element starts at 40 at the offset of 4 basically. Next element starts at 44, 48, 52 and so on. Now the question is, given any value of I and j, how to calculate this address? Now if I look correctly, let me take this example. Let's say I want to calculate the address of I is equal to 2 and j is equal to 2. So user or the programmer says, give me the element at the location I, 2 and j as 2. So ultimately I want to retrieve this number 8.3 which is present at the address 84. So in short, I have to calculate this 84 with respect to I and j values. So here if I see the arrangement, before this row, that is the second row, before this row the 2 rows are stored. So I can say I value here indicates this is the second row and before that row number 1 and row number 0 are stored. So I can say I value indicates the number of rows that are stored before this row. So let me write here 2 rows are covered so far up to the element 7.2 where the row number 1 ends. And how many elements are there in these two rows? Total 2 into 5. 5 columns in each row. So 5 into 2 into 5 will constitute total 10 elements. So up to the last element of the first row, total 10 elements are stored. So with respect to I can say I into m elements are covered so far. I indicates the number of rows covered so far and m elements in each row. And this is true for every element that you pick up. For example, I pick up this random element 1 and 2. What is the value of I? That is 1. So 1 into 5 will be 5. So before this row, 5 elements are covered so far. Alright. So this is a generalized formula. I can say I into m, which will give me total how many elements are covered up to the previous row. Now what about these elements which are covered in this row before the element we are interested in? So in this example, as I have considered I2 and J2, two elements are covered here, that is 9.0 and 4.9. And I can see that the J value indicates the number of elements covered in that row. So what is the value of J here? 2. So 2 elements are covered, 0 and 1. If I take J value as, let us say, the last element, that is 2 and 4. What is the J value? That is 4. That means in this row, so far, 4 elements are covered. That is 0, 1, 2, 3. That are 4 elements. So simply I can say the value of the J indicates the number of the elements covered in this row so far. So if I add up these two formula, I into m and J, I get the total number of elements covered before the element I am interested in. So in short, the total number of elements covered so far is 12. So if I put the I value as 2 and m value as 5, 5 into 2 will be 10, and 10 plus J value is 2 also. So 10 plus 2 is 12. So 12 elements are covered so far. Now consider one element size is 4 bytes. So if I consider that, what is the total number of bytes taken by this 12 elements? Obviously it will be 12 into 4, that is 48 bytes. So starting with this location 36, total 48 bytes have been covered so far. So far means up to the location of I and J. And after that, the element I is equal to 2 and J is equal to 2 starts. So if I put in the formula, it is nothing but I into m, that is total number of elements into the size of each element, considering here 4. In your case, if your data type is different, then you need to multiply by the size of one element. So as I said, what will be the location of 2, 2? That is I2 and J2, that is starting with 36 plus 48 is equal to 84. So at the location 84, the element from the 2D array, that is 2, 2, starts. So to generalize the formula, location of I and J is given by the base address, whatever be your base address. Here in my case the base address is 36, plus the total number of bytes before that element. This formula is called as retrieving formula. Why it is called as retrieving formula? Because you see, from the user point of view, if I provide any value of I and j, it is going to give me the location of that element in the memory. And once you get the location of that element in memory, you can access that element either for reading or writing. Now let us look at the implementation of this row measure order with the help of C++. Now let me assume that I want to declare the 2D matrix or the 2D array having 20 rows and 30 columns. So basically it's a 20 by 30 two-dimensional array. So how many total number of elements? 600 elements I need to store. And to store these elements in one-dimensional array, I am going to declare a pointer which will be my base address. Now let me write a function that is create 2D array with the number of elements 20 and 30 I pass. And here is the function I write, which take two arguments, number of rows and number of columns. So here I am going to show you how to declare a 2D array dynamically. So as I know, there will be n into m total number of elements, that is 600 here, and multiplied by the size of each element. And you know that in C++ we can get the size of data structure with the help of size of operator. Alright, so 600 into 4, that is 2400 bytes I need to allocate to store this 600 elements. So with the help of malloc, I allocate all the bytes that are required to store these 600 elements and capture the address of the first byte, which is stored in the x. Let's assume that x is a global variable I have taken here. Now let's say I take the input from the user that which element you need to store and what is the value you need to store. So I'm asking the user, give me the row number, that is I, and give me the column number, that is j, and at this row number and column number what value you want to store. So once the user gives the input I, j and the value need to store, I am going to write a function called as store element at the location of I and j. See, this is with respect to the programmer, right? This is with respect to the user, I can say, and the value. So I am going to write another function called as store element, which takes three arguments I, j and value. And first, with respect to I and j, I need to calculate the location of the element number I and j, that is row number and column number. So as I said, what are the total number of elements before this element? This means I and j, whatever value is passed. So before this element, the total number of elements are given by I into m plus j, same formula as I have discussed. And just add it to the x. And x plus the total number of elements before this element will give me the location. So location is a pointer here of size integer. And the next line would be value at that location is equal to whatever value the user need to store. And that's how, with the help of this retrieving formula, I can first calculate the location, and using a pointer, that is value at that location, I can access. Here I am storing the value at that location. Now what about getting an element? Let's say the elements are stored one by one by the user. And now let's see how to get the element, how to retrieve the element provided the value of I and j. So let's again say that I ask the user what element you need to retrieve from which row number in I and which column number, that is j. Let's say the integer element, and I write another function called as getElement, which again takes two arguments I and j, and using the same formula I retrieve the location of this element and value at that location is my interested value, and I just return the value to the caller and I get the element present at the row number and column number. So remember, either to store the value or to retrieve the value, I need to use the retrieving formula. And I finally print the element on the console. Now let us look at the implementation of column measure order. Let me take the same matrix again, credits, 3 rows and 5 columns. So first I need to store this in the one-dimensional array. So by column measure order, the first column will be stored as the first 3 elements of the array, followed by the next column, the third column, the fourth one, and the fifth one. So that's how, if you see the arrangement of these elements in 1D array, it is column by column. And once I store these all these 15 elements column by column, now it's simple to store this 1D array in memory. But here also, I need to calculate the location of the element with respect to I and j. So let me show here, with respect to I and j, what is the arrangement of these elements. So here I value varies from 0 to 2 and j value varies from 0 to 4. So as I have stored the first column here, what is the I value for the first element in first column? That is 0, 0. What is the second element in the first column? That is 1. I value is 1 and j value is still 0. So here 1 and 0. And similarly, the third element of the first column, that is row number 2 and column number 0. So 2, 0. So here the first column ends. And then the next column, that is 0th row and first column, first row and first column, and second row and first column. Similarly, with respect to index, I have shown all these elements. Now, let's do the similar calculation for the column measure order also. Now let me again take these addresses, starting with the address 36, and the size of element is 4 bytes. So at the offset of 4, all the elements are located. And the same question I ask, what is the location of the element if I provide I and j? So we need to come up with a formula here also. So let's consider here I need to calculate the address of I is equal to 2 and j is equal to 3. That is second row and third column from the index point of view. Now here, if I observe carefully, if I want to calculate the location of this 2, 3, before this column, how many columns are covered so far? See here, blue colored, orange colored and green colored. These 3 columns are covered so far in the one-dimensional array. And I can see the value of j tells me that. So 3 columns are covered so far, and total how many elements? That is 3 into 3 elements each. So total 9 elements are covered so far up to 72. Address location 72. So if I talk about this formula in terms of variables, J indicates the number of columns covered so far. So in general I have written J into number of elements in each row. You see, it is exactly opposite of the row measure order. There we wrote I into M. Here I am writing J into N. And in this column, how many elements are covered so far? And that is given by the I value. You see, if I value is 2 here, means before this element, this means 9.0. Before this element, 2 elements are covered, that is 5.6 and 8.2. So, I value indicates the number of elements covered in this column so far. So total, how many elements are covered so far? That is J into N plus I. So let's get the retrieving formula now. So total 11 elements are covered. One element, let's assume, of size 4 bytes. So 11 into 4, total 44 bytes are covered so far. Talking about the variables, total number of elements are J into N plus I. Assuming size of each element is 4 bytes. So the total number of bytes that is covered so far is multiplied by 4. So this calculation gives me the number of bytes covered before this element. This means whatever be the value of I and J. So I can say what is the location of 2, 3? 2, 3's location is base address, that is 36, plus how many bytes are covered so far? That is 44, and the address is 80. So similarly, I can write the formula I can write the generalized formula, the location of I and J is given by whatever be the base address of the one-dimensional array plus how many bytes are covered so far. And that gives me the exact address, that is the location of the element. Now let's look at the implementation of this column measure order with the help of C++. Now here again, let me take n value as 20, number of rows 20, and number of columns as 30. And here also I am going to take the base address pointer, which is x. So similarly, I am going to write one function here called as create two-dimensional array by passing the number of rows and columns. And let me take this function here in which I have allocated the total memory required to store all the elements. In short, I am defining the one-dimensional array here with the help of this malloc function. So in the 1D arrays, I have told you how to allocate the memory dynamically for the given number of elements. So here n into m, total number of elements and the size of each element. And I get the base address of the one-dimensional array. And with respect to this base address, I am going to access all the rest of the elements of the two-dimensional array. Now, how to store the elements? I ask the user, give me the input, what will be the value of I and j, and what value you need to store means what element you need to store at the row number I and j. So let me take another function store element here also. And similarly, providing the value of I and j and the actual value I need to store there. First, I use this retrieving formula that we have just written and add it to the base address. Remember that I have not multiplied the number of elements here. See, j into n plus I indicates the number of elements so far. I have not multiplied with 4. Why? Because if you add x plus number of elements and x being the integer type pointer, it will automatically add the offset of 4. You don't need to multiply the number of elements by the size of each element here. That was just a retrieving formula to get the exact location. So the offset is automatic added by the integer pointer here. So base address x plus number of elements gives me the location of that particular element, and value at that location I store. And how to get the element present at the I and j? Again, let me take a local variable element and I write a function getElement to which I pass the value of I and j. And this function will first calculate the location of that element by using the same formula. And once I get the location, value at that location gives me the element value. So that's how we reached to the end of this topic, two-dimensional arrays. We learned two-dimensional arrays can be stored in memory in two ways, row measure order and column measure order. And for both the row measure order and column measure order, we have two different formulas to access the elements. And from the user point of view, the data structure is two-dimensional because we are asking the user to provide the value of I and j, but programmatically we are calculating the location of I and j from the memory point of view. In the next session, I will continue with the two-dimensional arrays, where I will discuss how to store the lower triangular matrix. It is also the matrix, but it is one of the type of matrix called as low triangular matrix. How to store it in memory and how to retrieve it from the memory. Thank you for watching the video. If you have any comments or questions, feel free to put in the comment box. Have a great day.